With the help of ray diagram, which we have learned earlier, we can understand the image formation by concave mirror. And with these diagrams, you will be able to find out the size, position, as well as the orientation of the image formed by concave lens. So we will take a first case where the object is kept at infinity. Here in all the cases, to draw the image of the object, we will consider the 2 points, the top and the bottom points of the object, and we understand that the rest of the points in between will follow the same pattern and we'll get the image, and we know that the other points in between will follow the same pattern and the image will be formed. Here we are considering the first case where the object is kept at infinity. We know that if the object is at infinity, the light will come parallel to the principal axis, and what we have discussed earlier, we can say that they all will converge at focal point, principal focal of the mirror. So with this, for the object at infinity, the image is point size, which is highly diminished, position is at focus, and it's real because the light rays are actually converging at that point. Next case we'll consider when our object is kept away from, in this case, to take the image of the top point, we will take one ray which is parallel to the principal axis passing through the focal point. Ray 2 we will consider which is passing through the center of curvature, and obviously it will retrace itself back. These two rays are meeting at this point where they will form the image of point A, the top point of the object. For the bottom point we will take the ray which is going through the principal axis and which is coming back in the same direction, this ray, and that will be the position of its image. So image A dash B dash is formed there. In this case, image you can see, no need to mug up, you can understand it very well. It is diminished, you can see. It is positioned between C and F. It's real and inverted. Another case, we keep moving the object towards the mirror. When the object is kept at C at the center of curvature, with the ray diagram, it's clear that its image will be A1, B1 formed at C itself. And here, image is of the same size. It is at C at the same position, and image is real and inverted because light rays are actually converging at that point. Next case, when the object is moved further closer to the mirror, kept somewhere between C and F, here we will consider two rays, one passing through the principal axis, another moving parallel to the principal axis, and we know that they will converge at a far point which is beyond C, and the image is formed which is larger. So in this case, the properties of image will be magnified beyond C. Again, it is real and inverted. When the object is kept at focus, we will take a ray which is emerging from the center of curvature, which it will retrace itself back. Another ray we take which is parallel to the principal axis and it will pass through the focus. So you can see that these two images are parallel to each other. So we presume that they will meet somewhere at infinity. So in this case we can say the image will be highly enlarged. All the light rays are parallel to each other, seems to be converging somewhere at infinity. So image will be at infinity, highly enlarged, and obviously will be real and inverted. You can see here light is following the law of reciprocity. Remember the first case when the light rays, when the object is kept at infinity, we found the image formed at the focus. Here it's just the reciprocal of the same when the object and image are interchanging their position. Next case we will take where the object is kept very close to the image between focus and the pole of the mirror. The ray diagram shows that the reflected rays are moving closer to the mirror, kept somewhere between principal focus and the pole of the mirror. The ray diagram shows us that light rays are diverging. They don't seem to be meeting anywhere in real. An observer, they will be like emerging from behind the mirror, which is A1, B1. So in this case, this is an exceptional case in the case of concave mirror. Clear from the diagram that it is enlarged or magnified. In this scenario, the image is virtual and erect. Okay, we have discussed about the virtual and the real images earlier. So virtual image means the light rays are not actually converging at that point, but appears to be converging at that point, and virtual images are erect.